Hey, in this tutorial we're having a look at section 12.4 on measures of centre and spread. Okay, so our expected or mean value, okay, e of x, which equals mu, okay, is found by integrating from a to b x times f of x dx, where x is an element of a to b. So whatever our probability density function is, f of x, we multiply it by x and integrate and we find our expected value. Okay. If we need to find our expected value of g of x, okay, then we integrate from negative infinity to infinity of g of x times f of x dx. Okay, or if x was an element from a to b, you'd also go from a to b instead of our negative infinities. Okay, our variance, okay, is still equal to our original idea of our variance, okay, which is that the variance of x, okay, is equal to e of x squared minus e of x all squared. Okay, so we need to think, well, e of x squared is equal to negative infinity to infinity, okay, of x squared f of x dx, okay, because it's like a case here. Okay, we've got e of x squared, okay, so it makes it that function there, so it just becomes x squared out the front instead. And our e of x all squared is just simply equal to our integral for negative infinity to infinity of f of x, x times f of x dx all squared. So just the way we found our expected value earlier. So we're already going to have found this expected value. Okay, so we won't need to do that again if we're trying to find our variance. And then for this one, we just need to solve this part here. Okay, and of course our standard deviation is just the square root of whatever our answer is for our variance. Okay, so that's nothing too new. It's just the idea of how we find them using our integrals. But honestly, it's very, very straightforward, just multiplying by x and x squared before taking our integral. Okay. Right, our median, for a continuous random variable x defined by the probability density function f of x, the median can be found by solving from negative infinity to m of f of x dx equals 0.5. Okay, because our median value is in the middle, so we set equal to 0.5. Now this negative infinity, it'll be your lower terminal. Okay, so if you do actually have a probability density function that's from 0 to infinity, something like that, okay, well you'd start at 0 and go up to m. Okay, it's just your lower terminal, okay, or your lower endpoint of your domain. Okay, similarly, if we want to find the lower quartile, okay, remember our lower quartile is the median of the lower half of the data, which means that we go from negative infinity, or our lower terminal, up to a and set equal to 0.25. Okay. Similarly for our upper quartile, okay, we can find that by going from negative infinity to b, okay, of 0.75. Okay, and basically our interquartile range can be found by doing our upper quartile, which is Q3, okay, minus our lower quartile. That just gives us an indication of the spread of our middle 50% of our data. Okay, basically, if you're asked to find the value of any quartile, so it could be the 0.8 quartile, the 80th percentile, okay, then you just set equal to 0.8 instead of 0.75, okay, and then solve for some upper value. Okay, so we'll have a look at some worked examples on this stuff. Okay, so worked example 4, okay, we've got a function f of y, which is defined as ky for 0 is less than or equal to y is less than or equal to 1, and 0 elsewhere. Okay, for part A, we're asked to sketch the graph. Okay, so sketching the graph will just simply look like this. Okay, so that's our graph there. Okay, for part B, we're going to find the value of k. Okay, well the area under here has to equal 1. So we can just do our area of a triangle and say half times our base times our height. Okay, well our base, that has to equal 1. So our base is 1, and our height is k, and that equals 1. So we can say a half k equals 1, so k will equal 2. Okay, in the book they go through and integrate, okay, but you really don't need to integrate when it's just a nice geometrical shape like a triangle. Okay, part C, find the mean. Find the mean of y. Okay, our mean or our expected value. Okay, so I'll just switch over colours. So remember, our mean is equal to the integral from 0 to 1 of, now it won't be x, but it'll be y times 2y dy. Okay, we're always going to multiply our function, okay, by y. Okay, so it's going to be from 0 to 1 of 2y squared dy. Okay, so that'll be our mu equals 2 on 3 y cubed. Okay, from 0 to 1. Okay, so mu, we got sub 1 in, we're going to get 2 on 3. Okay, take away 0, so it's just going to equal 2 on 3. So our mean value would be 2/3. Okay, and that's CI. CII is to find the median. Okay, so for our median, as we just spoke about earlier, is we've got to go from our lower one, which is 0, up to some point m, okay, of 2y dy is equal to 0.5. Okay, so when we integrate, okay, we get y squared of 0 to m equals 0.5. Okay, which means we're going to get m squared, take away nothing, equals 0.5. M squared equals our 0.5. So m equals plus or minus the square root of 0.5. Okay, so we can say that m equals plus or minus the square root of a half, which equals plus or minus 1 on root 2. Okay, and if we have a look at our domain here, it's from 0 to 1, so we need to ditch the negative. So m is going to equal 1 on root 2, which will be our median value. Okay, and part D is find the interquartile range. Okay, so what we need to do for this one, so we need to integrate, we'll say from 0 to a. So we're going to do our lower quartile of 2y dy is equal to 0.25. Okay, so that means that we're going to be y squared, 0 to a equals 0.25. Okay, so a squared is going to equal 0.25. Okay, so a is going to equal the square root of 0.25, which is the square root of 1 on 4, which equals a half. Okay, we also need to integrate, we'll say this time from 0 to n. It doesn't really matter what letter you use, of 2y dy, and set it equal to 0.75 this time. Okay, so we're going to get our our y squared from 0 to n equaling 0.75. Okay, so that means that our n squared equals the square root of, we'll say 3 on 4, which equals root 3 on 2. Okay, so that means that our interquartile range is going to be root 3 on 2 minus 1 on 2. Okay, you could write it in exact form as root 3 minus 1 on 2. Okay, in a decimal, okay, that equals 0.366. Okay, so that would be our interquartile range. Okay, so we'll have a look at the next worked example, which is worked example 5. Okay, so I've got a probability density function, f of x equals a half x plus 2 from -4 to 2, okay, and 0 elsewhere. Okay, we're asked to find the mean to start off with. Okay, so for our mean, we're going to integrate from -4 to -2 of x times a half x plus 2 dx. Okay, so that means that we're going to be integrating from -4 to -2 of x squared on 2 plus 2x dx. Okay, so that means that we're going to get, okay, x cubed on 6 plus x squared from -4 to -2. okay, which means we would be minus 2 cubed on 6 plus minus 2 squared minus negative 4 cubed on 6 plus negative 4 squared. Okay, so when we do that, we get that we've got 4 on 3 plus 4, okay, plus 32 on 3, okay, minus 16, okay, which equals negative 2 and 2/3. Okay, so that would be our mean. Okay, for part B, we've got to do our median. Okay, so this time we're going to be integrating from our minus 4 to m of our a half x plus 2 dx equals 0.5. Okay, so that means that we're going to integrate that. So we're going to get x squared on 4 plus 2x from negative 4 to m equals 0.5. So that means we're going to get m squared on 4 plus 2m. Okay, minus negative 4 squared on 4 plus 2 times negative 4 equals 0.5. Okay, so that means we're going to be m squared on 4, okay, plus 2m plus 4 equals 0.5. Okay, so what we're going to need to do is make it m squared, so we can multiply out by 4 and bring our 0.5 across. When we do all that, we get m squared plus 8m plus 14 equals 0. Okay, there's not a nice version of that. Okay, so we need to do our general quadratic formula. Okay, so when we do that, we find that we get m equals negative 4 plus or minus root 2 when we do our general quadratic formula. Okay, negative 4 is at the lower end of our domain, so we can't have the negative one because it'll take us outside our domain. So m will equal negative 4 plus root 2. Okay, and when we have a look at part C, okay, we need the variance. Okay, so our variance, remember, our variance of x equals our e of x squared minus our e of x squared. Now we already have our e of x, we found that earlier over here. Okay, so we need to find our e of x squared. Okay, so our e of x squared is equal to our integral, okay, from our minus 4 to our minus 2 of x squared times 1 on 2x plus 2 dx. Okay, so that means that we're going to be equal to our integral from minus 4 to minus 2 of our x cubed on 3 plus 2x squared dx. Okay, so integrate that. We're going to get x to the 4 on 12 plus 2x cubed on 3 from minus 4 to minus 2. Okay, just running out of a little bit of room here. Okay, so when we sub those in, okay, when we sub in negative 2, we get minus 30. Okay, when we sub in our minus 4, we get 112 on 3. Okay, when we bring those together, we get 22 on 3. Okay, so we can bring together everything that we need. Okay, so we've got now our variance of x equaling our 22 on 3 minus our negative 2 and 2/3 squared, okay, which is 22 on 3 minus 64 on 9, okay, which equals 2 on 9, okay, is our variance. Okay, and in part D, our last part, is we need our standard deviation. Our standard deviation of x is is equal to our square root of our variance. Okay, so that's going to be the square root of 2 on 9, which is going to be root 2 on 3. Okay, which equals 0.4714. Okay, so look, I don't think you'll have too much trouble with this section. Again, like you'll have to put in a bit of work and a bit of time. Okay, they're not too bad. It's only when we start to probably get into some of our variance work, okay, that can take a bit longer, just because we need to make sure that we've done our mean value first. Okay, so the main thing is, remember, for our mean, we've got to times everything by x, okay, before we integrate. When we're finding our e of x squared, okay, we times everything by x squared before we integrate. Okay, and essentially they're the main ideas from this section, so hopefully you'll get through without too many troubles.